Let's find the derivative of this expression. We have square root x to power 7 plus 1 into y plus y square x equal to 0. And we have to find dy by dx, meaning that we will have to differentiate with respect to x. Before we find the derivative of this expression, we will rewrite it in a simplified form. X to power 7 plus 1 whole power 1 by 2 into y plus y square x equal to 0. Now we will differentiate this expression with respect to x. So the first term is the product of two terms, which is x to power 7 plus 1 to whole power 1 by 2 into y. So we will apply the product rule to find the derivative of first term. So what does the product rule say? It says first term as it is. Here first term is x to power 7 plus 1 to whole power 1 by 2, and the derivative of the second term with respect to x. Second term is y, its derivative with respect to x is dy by dx, plus first term derivative. Since first term is x to power 7 plus 1 whole power 1 by 2, so we will apply the power rule. Power comes on the side, x to power 7 plus 1 by 2 minus 1, and then the derivative of the inside term, which is x to power 7 plus 1. So derivative of the inside term is 7 x to power 6 by power rule plus derivative of a constant 0, plus now the derivative of this expression y square x, which is in itself the product of two terms y square and x. So we will apply the power rule. First term as it is, and the derivative of the second term with respect to x. Second term is x, its derivative with respect to x is 1, plus derivative of the first term with respect to x. First term is y squared, its derivative is 2y dy by dx, and the second term as it is equal to 0. So we will rewrite this expression in a simplified form. Dy by dx plus 1 over 2 x to power 7 plus 1 minus 1 by 2 7 x to power 6 plus y square plus 2xy dy by dx. Since we have to find dy by dx, so we will combine the terms having dy by dx in them. So we have x to power 7 plus 1 square root plus 2xy, and the common is dy by dx. The terms that don't have dy by dx in them, we will take them on the other side with the change of the sign. So we have minus 7 x to power 6 by 2 x power 7 plus 1 to whole power minus 1 by 2 minus y square. So we can write it as dy by dx is equal to minus 7 by 2 x to power 6 divided by x to power 7 plus 1 minus y square whole divided by x to power 7 plus 1 plus 2xy. Since here we had the implicit expression involving both x and y terms, so when we find the derivative dy by dx on the right hand side, you can see that it involves both the terms involving x and y. This is how we find the implicit differentiation of the given expression. Let's find the derivative for another expression, which is sine x square y square plus tan cube xy square plus y is equal to y plus x, and we have to find dy by dx. Since we have to find dy by dx, it means that we will have to differentiate the given expression with respect to x. So we will write this expression first in a simplified form. We know that the positive power on a trigonometric function is also considered as the whole power, so we can write tan x y square plus y whole power 3 is equal to y plus x. Let's now differentiate this expression with respect to x. So we have to find the derivative of sine of x square y square. Here the angle is x square y square. First we find the derivative of sine of the angle, and the derivative of the sine of the angle is cos of the angle. So we have cos of the angle x square y square, and then we will write the derivative of the angle. Since angle is x square y square, which is as the product of two terms x square y square, so we will apply the power rule of derivative to find the derivative of this angle. So first term as it is, and the derivative of the second term is y square. Its derivative with respect to x is 2y dy by dx plus first term derivative with respect to x. First term is x square, its derivative is 2x, and the second term as it is, plus now we have to find the derivative of this term. So this term has the whole power 3. So first we will apply the power rule, which says 3 tan xy square plus y 3 minus 1, and now the derivative of the inside term, which is tan xy square plus y. Derivative of tan of the angle is secant square of the angle. So we have secant square, the angle here is xy square plus y, and then the derivative of the angle is xy square plus y. So first the derivative of the term xy square, which is written as the product of two terms x into y square. So we will apply the power rule. First term as it is, and the derivative of the second term, which is 2y dy by dx plus first term derivative. First term is x, its derivative is 1, and the second term as it is, plus derivative of y now. Derivative of y with respect to x is dy by dx is equal to y plus x. So the derivative of y with respect to x is dy by dx plus derivative of x with respect to x is 1. Let's simplify this expression. Cos x square y square, it's multiplied by the first term, which is 2x square y dy by dx. The second term is 2xy square cos x square y square, plus we have 3 tan x y square plus y. 3 minus 1 is 2. We can put it as the power on tan secant square x y square plus y. This whole term is being multiplied by 2xy dy by dx plus y square plus dy by dx is equal to dy by dx plus 1. So again simplifying it further, we have cos x square y square 2x square y dy by dx plus 2xy square cos x square y square, plus now we are combining this with this term and this term. So we have 2xy plus 1 multiplied by 3 tan square xy square plus y secant square xy square plus y into dy by dx, and another term is 3 tan square xy square plus y secant square xy square plus y into y square, it is this term, is equal to dy by dx plus 1. Now we can see that the terms that have dy by dx in them are this term and this term and this term. So we'll combine these terms keeping dy by dx as common. It gives us dy by dx cos x square y square 2x square y plus 2xy plus 1 3 tan square xy square plus y secant square xy square plus y minus 1, which is this term. And on the other side we have minus 2xy square cos x square y square minus 3 tan square xy square plus y secant square xy square plus y into y square plus 1. So from here we can keep dy by dx on one side, and by doing the cross multiplication we have this expression for dy by dx. This is how we find the implicit differentiation for this given expression. In the next videos we will try to find the derivative by using the concept of logarithmic differentiation.